control of DC motors by choppers. Okay. So before going to the actual subject, we will discuss some introduction about choppers. Choppers are used to get variable DC voltage from a DC volt source of fixed voltages. Okay. So these are the choppers. Choppers are used to get variable DC voltage from a DC fixed voltages. That is called fixed DC to variable DC converters. Choppers are like a fixed DC to variable DC converters. So by using these choppers, the voltage increases and decreases. That means this by using these choppers, so it is possible to increase the voltage or decrease the voltage. So that like a transformer. Okay, generally these choppers are called as a DC transformer. Okay, so this self-commutated devices. Self-commutated devices such as MOSFET, MOSFET, power transistors, IGBTs, GTOs, and IGCTs are used for building choppers because they can be commutated by low power control signals and do not need commutation circuit. Do not need commutation circuit and can be operated at a higher frequency for same range. So this is the advantage of this devices, self-commutated devices, MOSFET, IGBT, GTOs. So these are all the self-commutated devices. Okay, external commutation circuit is not required. That is called forced commutation is not circuit is not required. But in thyristors, the forced commutation is required to turn off the thyristors. Okay, so then choppers offers number of advantages. Choppers offers a number of advantages for a control rectifiers for a DC motor control in open loop and closed loop configurations. Understand? Choppers offers a number of advantages over a control rectifiers, that is called single phase semi-controlled rectifiers, single phase fully controlled rectifier, and also three phase semi-controlled, three phase fully controlled rectifier. Okay, choppers offers a number of advantages over this controlled rectifiers for a DC motor control in open loop and closed loop configurations. Is it clear? The operation at high frequency improves motor performance. The operation at high frequency improves the motor performance by reducing the current ripples. So you know the relations that ripples current delta IL is inversely proportional to the frequency. Okay, so these devices are operating at high frequency, means the ripples current ripples are reduced. Okay, the operation at high frequencies improves the motor performance by reducing the current ripples, because a reduction in armature current ripple, okay, reduces in machine losses and it is derating. Machine losses and it is derating and eliminating the discontinuous conduction. So these are the simple. So one of the advantages of this. This choppers converters, and next this elimination is discontinuous, and this elimination, so that this discontinuous conduction is eliminated. That means the elimination of discontinuous conduction, so region improves the speed regulation and transient response of the drive. Okay, understand? Then some of the advantages of the chopper controller. So advantages of using chopper in speed control of DC motors are high efficiency, flexible in control, light in weight, small size, and quick response, and generation down to very low speeds. Regeneration is down to very low speeds. Okay, these are some concepts regarding the choppers introduction, and then we will go for next concept, that is called. Okay, so then we're concentrating on this concept that's called types of DC choppers. Types of DC choppers. Here, this is called single quadrant chopper drives. It's called classified into three types. First one is called single quadrant chopper drive, two quadrant chopper drive, and four quadrant chopper drives. So these choppers can be classified into three types: single quadrant chopper, two quadrant, and four quadrant. Single quadrant chopper is nothing but so only one quadrant operation. Did right? Okay, that is maybe motoring mode or regenerative mode. Regenerative mode or motoring mode. Only one quadrant operation. So motoring mode or regenerating mode is called a single quadrant chopper, and then two quadrant chopper is nothing but is operating in two quadrants. Motoring mode and regenerative braking mode are okay, and motoring mode or reverse regenerating braking mode. So this type of two quadrants, first quadrant and second quadrant, are first and fourth quadrant operation of the drive is called two quadrant chopper. But is here only first quadrant operation, otherwise second quadrant operation of the drive is called single quadrant operation. Chopper drives. Okay, and fourth quadrant chopper drive is nothing but is fourth quadrant is operating in fourth quadrant operation. First quadrant, second, third, fourth. So fourth quadrant operation is the fourth quadrant operation. That means forward motoring mode, forward braking mode, reverse motoring mode, reverse regenerating mode. Okay, this single quadrant is nothing but motoring mode and forward motoring mode, or otherwise forward braking mode is called a single quadrant chopper. Two quadrant chopper is called forward motoring mode and also forward braking mode. It's called two quadrant chopper. First quadrant and second. Otherwise, first quadrant and fourth quadrant. Forward motoring mode or reverse regenerating braking mode. It's called a two quadrant operation of the chopper. Understood? So this choppers I can classify into like this types of choppers. First one is called type A chopper, first quadrant chopper. So this color is also called as a type A chopper or first quadrant chopper. So this is called forward motoring mode. In the first quadrant, the motor is this machine is acting as a motor. That's why this is called as type A chopper or first quadrant chopper, forward motoring motor. Okay, and then type A chopper. So second quadrant chopper. So that is called forward braking motor, forward braking mode only. So this comes under, these two are comes under single quadrant chopper. Okay, first and type A chopper and type B chopper, these two are comes under single quadrant chopper drives. Understood? So that is nothing but first quadrant means forward motoring mode and forward braking mode chopper drives. So under first quadrant, and then type C chopper also is called as a two quadrant type A chopper. Type C chopper or two quadrant type A chopper. Understood? So these are also called as a forward motoring mode and forward braking mode, two quadrant operations. So this is called as a this is under two quadrant chopper drives. Okay, two quadrant chopper drives. So the type C chopper or two quadrant type A chopper is also called as a two quadrant type A chopper. That's called forward motoring mode, otherwise and forward braking mode. It's two quadrants almost. Okay, and then type D chopper is also two quadrant type B chopper. So type D chopper is also called as a two quadrant type B chopper. Understood? Type C chopper is also called as a two quadrant type A chopper. So here forward motoring mode and reverse braking mode. So here first type C chopper is operating in first quadrant and second quadrant, forward motoring mode and forward braking mode. But here type D chopper is operating in for motoring mode means first quadrant and reverse braking mode means fourth quadrant. Okay, this is called type D chopper, and then type E chopper, type E chopper is also called as a fourth quadrant chopper. Fourth quadrant chopper. Okay, so four quadrants operating. This type E chopper is operating in four quadrants. Okay, and type A chopper is or first quadrant chopper. So it's called forward motoring mode. So this is called circuit diagram of this type A chopper. Understood? This is called a type A chopper. So this first quadrant operation of this chopper. So first quadrant operating. The chopper drive is operating forward motoring mode. So that's why first quadrant operation. So motoring mode. So type A chopper is the first quadrant chopper or forward motoring mode. So this is the circuit diagram of the type A chopper. So this is the circuit diagram. So we will discuss later. So just try to concentrate. So only I'm explaining types of choppers only. So discuss completely working principle. Now it is operating. Okay, so next classes. Okay, so first quadrant chopper, type A chopper or first quadrant chopper. It's called first forward motoring mode only. So it's operating in the first quadrant. That is called forward motoring mode. That is called voltage and currents are positive. That is speed torque characteristics. So if it is speed, your torque. Okay, torque is proportional to current, and the speed is proportional to the voltage. Okay, your speed and torque. That means speed and torques are so same. So positive sensitivity. That is why it is a so motoring mode. So this is called first quadrant type A chopper. Okay, these are so these are the different types of choppers. I'm already explained. Okay, type A, type B, type C, type D, type B. First, we will discuss only circuit diagrams. So, type A chopper is also called as a 4-quadrant chopper. Understood? And then this is called type A chopper. So we'll discuss later classes so in detail about type A chopper, and then coming to the type A chopper. Type A chopper. So this is the circuit diagram, and this is the operating mode of the circuit. So here, type A chopper or second quadrant chopper is a forward breaking mode. That means, so here second quadrant. So understood. Type A chopper is also called as a second quadrant chopper. So is operating in the region of forward breaking mode. So in this forward breaking mode, so this is called voltage, nothing but the speed. So voltage is proportional to speed, and torque is proportional to the armature current. So that's current is reverses. That means here type B chopper, it is current is reverses. Okay, it so but speed is same. That means the motor is your load. For example, your load, the DC motor. Okay, the DC motor is rotating in the same direction. The rotation of the direction of this motor is same direction, same as the first quadrant operation. But here operating torque is in opposite direction. Okay, so that's why the acting as a braking. Okay, but rotor is rotating in the same direction as same as motor, but the torque applied when the rotor is opposite direction. That's why it's called forward braking mode. Okay, this is called type B chopper or second quadrant types choppers. Okay, understood. Then type B chopper is over, and then type C chopper. So then we'll go for type C chopper. So here type C chopper are 2-quadrant type A chopper. It's also called as a 2-quadrant type A chopper. Okay, forward motoring mode and forward braking mode. So first quadrant and second quadrant, 2 quadrants operating by using this valve. Okay, it is operating 2 quadrants. Type C chopper is also the 2-quadrant type A chopper. Forward motoring mode and forward braking mode. 2 quadrants, first quadrant and second quadrant. This is the circuit diagram and this is the operating modes. Here motoring mode and forward braking mode. So it is also called as a combination of type A and type B chopper. Okay, so here is called type A chopper and the first quadrant is called type A and second quadrant is called type B. So this is a combination of type A and type B chopper is also called as type C chopper. The 2-quadrant type A chopper. Okay, forward motoring mode and forward braking mode. This is the circuit diagram. Okay, this type C chopper. Then type D chopper. Type D chopper. This type D chopper is also called as a 2-quadrant type B chopper. Type D chopper is also called as a 2-quadrant type B chopper. So it's operating in forward motoring mode and reverse braking mode. So it's called forward motoring mode and reverse braking mode. Forward motoring and reverse braking. Understood? So this is the circuit diagram of this type D chopper. So here this called voltage and the current characteristics are like this. The voltage and the current speed torque region operating modes is like this. Here forward motoring mode and reverse braking mode. So forward motoring mode and reverse braking mode. Here this forward motoring mode is here. This rotor is rotating in a clockwise direction. For example, the rotor is rotating in clockwise direction. Okay, and here this rotor is rotating anti-clockwise direction, but the torque acting on this motor is the opposite direction. Here torque direction, same. Okay, because of the current armature current flowing through the motor is positive direction. So positive, but voltage changes. Here voltage V0 and here V0. So here, so power is nothing but V0 into I0. So here power is taking from the source. This drive is taking power from the source, and but here power is equal to V0 into I0 minus V0 into I0. That's why it's delivering the energy to the source. Okay, it is rotating in the reverse direction. Okay, so it's rotating in the reverse direction. It's rotating in the for example, it is rotating clockwise. It is rotating anti-clockwise. But torque acting on this motor is the same direction, but rotations are different. Okay, so in details we have to we'll discuss in next classes. So about these choppers types. So type D chopper is also called as 2-quadrant type D chopper. The operating region is called forward motoring mode and reverse braking modes. Understood? This is called type D chopper, and then finally type E chopper. So type E chopper is also called as a 4-quadrant chopper. 4 quadrants. It's operating in the 4 quadrants: first, second, third, fourth. Okay, it's operating in the 4 regions: the first and the second, third, fourth. That is nothing but forward motoring mode, forward braking mode, reverse motoring mode, reverse regenerative braking mode. reversible generating braking mode. So these operating in the 4 quadrants. That's why it is called as the 4 quadrant operation of Chapu gears. Okay, this is the circuit diagram. This is the so operating in more regions of this type each other. Okay. So this is about types of channels.